Hello everyone, and thank you for joining me in this session about browser security and HTTP headers. I've got two things before we start. The first one is that you probably noticed I'm French, so I hope you won't mind the accent. I'll try to mask it, but... the second one is, how many of you are here in DevOps Belgium for the first time? Nice, me too. And I'm already enjoying it. And I'm already sad that I missed the previous version. But the funny thing is that when I looked at the program to see my schedule and also my room, I saw room number 5. So I thought, doesn't sound like a plenary. It sounds small. So who am I? Mathieu Humbert. I'm tech lead at Accenture. I'm most importantly, backend dev since 16 years. And as a daily basis, I'm doing architecture, DevOps, and security, which brings me here to discuss about those subjects. But I'm really thankful you're here, but I'm also wondering why. I mean, HTTP headers, what's the big deal about it, right? It's simple, we all know about it, and also what kind of security does that bring? I mean, we could talk about SQL injection or remote code execution, 0 days, this kind of stuff. That's the real stuff, right? What about HTTP headers? As a matter of fact, there is one header we see more often than not in many projects, and that's this one. I don't care. Strict, I don't care. So yeah, let's be honest, this stuff is usually postponed on a project or any product before we ship it in production. That's what we tell ourselves. And before we ship, we forget. So there is a small variant of it, like this one. Basically what happens is that single origin policy comes in the way, so we just disable it altogether, wildcard everything. And all that to tell you that some kind of attacks, XSS, CSRF, clickjacking, that we will talk about today, are having a really good time these days. Those are the numbers of CVs reported in 2021. The drop here don't count because it's 2022 is not finished and those numbers are old, but the 2022 numbers are very likely to be higher than that, higher than 2021. By the way, I guess you know, but CVs are those reported vulnerabilities in any of the software we use. So we're going to talk about those attacks, CSRF, XSS, and clickjacking, and I promised a demo. So let's get to it. But before that, I'll give a little bit of context. I've got a little story about this YOLO conf. So let's imagine out there is this amazing conference, less amazing than DevOps Belgium, of course, but amazing still, tech conference. And this kind of tech conference works with CFP, call for papers. So there is those talks that are proposed by anyone, and then the organizers are reviewing them. So you need a tool about that. And in all of this, let's say that I'm quite a bad speaker, and well, no, that's true that. But let's say that on top of that, I'm a little bit of a rogue person, and I'm so fed up by being rejected all the time that I decide that I'm gonna hack the CFP and cheat. So let's do that. Or really, I said I'm gonna hack the CFP of a tech conference. How terrible is that? That's supposed to be the moment where you say, boo. Yeah, it does not seem to be like a bad idea to you, right? Anyway, let's get to it. So, I'll present the tool. So, you'll see my amazing HTML, CSS skills. This is a basic Spring Boot app. And one of the core aspects of a CFP tool is the public form where you can post a new talk, right? So you've got this part, and then for the organizers, of course, it's authenticated so that you can review the talks, and it's authenticated with this very secure password that you could never guess. So here I've got this tool where two talks have been submitted. One of them is mine, and my goal will be to hack an organizer, my victim, to actually accept this talk without his consent or her consent. All right, so let's do it. So where do I start with that? Non-techie thing. I might start with some social engineering. I need to see what my victim is, and I'll look at the social media, I look at Twitter and LinkedIn, and I quickly see that my victim is a big fan of travels and photography. So I'll use that and build a phishing site on which I'll do the stuff I will present you, but then I need to share that phishing site to my victim. So I'll be patient, and I'll wait for him or her to post on social media and say, "Oh, I'm just coming back from Antwerp. Such an amazing city." And then I'll reply and I'll say, "Oh, that's fortunate because I'm also coming back from Antwerp like 2 weeks ago, and I also did some pictures, not as good as yours, but still, I would really appreciate if you can go to my blog and check my pictures and tell me if they are good or not. Here is a link." So my victim accepts. I'm looking like a good guy. And here is my site. Yeah, well, CSS skills. Let's pretend it's more advanced phishing. But anyway, on this side, let's say there is a first text to explain the trip. And then if you want to see the pictures, you've got to click here, right? Do I do it? I'll just refresh the page for the purpose of the demo. And I'll click. I'm the organizer, right? I click. It doesn't work. Oh, gosh. Such a rubbish site, right? Oh. I did have something else more interesting to do as an organizer, right? So where was I? I needed to review those talks. Let's refresh the page. Oh, surprise! What did happen? So let's view this phishing site. Let's inspect a little bit. Like to. Cursor is tricky. All right, and then I don't know if you can see that this iframe at the very bottom, right? That wasn't an iframe. Yes, there was. What did this iframe did? Of course, it worked, right? It worked. And that is called clickjacking. So I put the little clown in it because, honestly, that's the most ridiculous attack that there could be. But it worked. It works. And how did it work? Basically, two things. First one is iframe, of course. And the second one is because we are on the same browser session. So all the cookies of the session for the CFP are coming with it. So what do I do about it? I'll first try to secure the iframe. First, headers. This talk is about headers, right? So first header, very easy to implement, X-frame options. This headers is saying, my site I don't want to it to be injected into an iframe ever. So browser, please, you see what I'm saying? Do not inject my site into into an iframe. So you can have deny, so no iframe period, and you can have same origin, which says, okay, why not iframe, but only if the iframe is actually on a page where coming from the same origin. So you could go also a little bit higher or further with the content security policy, which will go furthermore later on. Content security policy is the Swiss Army knife of the headers. You'll have to know this one. And one of its options is about the iframes, where you can do basically the same thing as Xframe option, but you can also specify external domains that you trust. That's pretty cool. And then just one little note, I see way too often on some project techniques about hidden iframes, especially for like transparent re-authentication and these kind of things. Please avoid, it's messy. All right, that was for the clickjacking. Let's come back. Oh, one thing. Wanted to show you this. So, I've got to be honest, I cheated a bit because I'm using not only Spring Boot but also Spring Security, and this header is easy enough to implement that it's implemented by default on some framework, not all, but one of them is Spring Security. You can have it also by default on some web application firewall, but you have to check if you have it. So here I actually disable it for the purpose of the demo. But if I didn't, here, what would have happened? All right, I have the same iframe, and then Firefox can't open this page. Here is the purpose of the Xframe option. All right, so now that we have this option, what do? This security, and we can't use clickjacking. Let's give it another try. Let's pretend I've got a second version of my phishing website. And this time, so we go back in time, and let's pretend I send this V2 version from the get-go. So here, I've got my victim going here, right? Oh, no. First thing, because otherwise you won't see the difference. All right. So let's pretend my victim goes to this site and immediately sees it's a phishing website, right? I mean, oh, rubbish it looks like. So not clicking anywhere and coming back to the talks. Accepted again. Cool. What did happen? This time, it's even more straightforward, right? Really easy to understand. So let me refresh. I've got this Ajax call, and that's it. I mean, how come? Ajax call to the specific endpoint that is actually changing the status, the one that is behind the button, the green button. I'm calling it directly, and that works from my phishing site. Again, because I'm on the same browser session, right? The cookies are going along with it. So we'll see why in a second, but first I'd like you to remember these cores missing, because I'm gonna talk about it later on. Here you can see that I get a 302 because afterward there is a redirection, but the action was indeed successful. So why was it successful? Because of, so first thing, this is called CSRF, cross-site request forgery. It's a barbar name, but behind it's very easy, very easy. And what's behind it? It's cookies. What's the premise of cookies? It's just you set it beforehand with a key and value, and then it's supposed to be sent along with any of the queries made to the same domain, right? By default. And please bear in mind that cookies are here from like the 90s. In the 90s, the concerns for security were not the same as in 2022. All right? So cookies, I said cookies are set with key and value, but of course they have options, and we have to know those options. That's where we secure cookies. One of them is called SAMsite. SAMsite, what it says, it's for browsers saying, okay, I set this cookie, but please do not send it along when the request comes from across domain. The request comes from something else. The value is lax, and then the browser will just not send the cookie. Will do the query, but not send the cookie. You've got further options like strict, where this goes up to the HTTP link. Like you could have this attack where I send a link which is directly pointing to .fr, and have the user click on it, do the action. That wouldn't be subtle at all, right? The person would notice it straight away, but the action would be done. Strict could help here. But at the same time, there might be some API design issues, right? Because all I'm interested in CSRF is write actions. If I do have a write actions on a get link, maybe something to revise on the design. All right, and one very important thing. This option is called SAMsite for a reason. You might have heard about origin on many options, and origins. We know that it's the whole path and schema. You've got the schema, you've got the subdomain, all the domain, even the port. But the site, the concept of site, comes back from the 90s, and it's way less strict. It's just what we call the ETLD +1, meaning that just what's behind the .com, before the .com, before the .be. What we call ETLD is something that is listed. So you've got all the .com and consort. You might have specific sites that provide some specific platforms, like I think GitHub might be on those, Heroku, for instance, but it's very restricted. So in this example, domain is just example site. What that means is subdomain are not secured with the SAMsite option. And that's going to be important in some later part of the talk. But I'm talking about CSRF, and I need to diverge a bit from headers, because I can't talk about CSRF without talking about CSRF token. That's a real mean of securing against CSRF. What is CSRF token? It's a way to authenticate any form on your application. It ties the form UI to the backend. And the way, what it does is that the backend is generating a token, ideally on the fly for any form, which is generated and rendered within the form UI. And then whenever someone posts a form, it needs to go with a CSRF token with it. Otherwise, you get rejected with a 403 forbidden. So we're going to test that. Because again, second sheet. Spring Security is doing that also by default, but again, we don't have Spring Security everywhere. So here we go. If I disable it, if I stop disabling it, actually, what happened is here I'll redo the same thing, and actually I need to come back and OK. Okay, so we've got the talks here, and I come back to my phishing page, v2. Here you go. And here I still do the query, right? But instead I get a 403. I get a 403 because I don't have the CSRF token, which is expected on the backend side. And just to prove it to you, it didn't work, right? This time. And if I inspect the page, and I go on the button, then you can see here the hidden field, the CSRF token, which was mandatory for the post of the of this form. All right, so that's CSRF token. But to come back to headers, because we diverge a bit. To come back to headers, I can talk also about the headers that didn't help on this one, and try to kind of debunk some myth. Remember, I asked you to look at the error we got in the first place. While successful, we had this CORS error. So we need to talk about single origin policy and CORS, cross-origin resource sharing. What we think is a security that prevents some requests to be made between cross-domain is actually the single origin policy. That's the one which is applied by default on browsers. CORS are those headers that tries to loosen a bit the security. That's why we apply those CORS headers with wildcard at the beginning of the project. Don't do it. But to understand how it works, is that this security is on the browser side, right? And to be efficient, it needs information from the backend side. So the standard way of applying the single origin policy is that a request is asked to be made. So the browser will do it, and then when the backend comes back with a true 100, the browser will look at the headers and try to see if there is CORS aligned with this cross-domain request. And here in my case, I didn't have any CORS, and I didn't have any CORS wildcard. I didn't have anything. But what happened is that the requests were made, and the CORS kicked in too late. They kicked in when the response come back. But as an attacker, I didn't care at all about the response. All I wanted is the request to be made, the action to be made on the backend side. That's why it was successful while being displayed in red by the browser. So you might say, okay, but there is this pre-flight mechanism, right? I see that all the time. What is a pre-flight is a smart solution to this problem, which is I've got a browser would have a request to make, but don't have the CORS information. So what it would do is not send the initial request, but send another, which is what we call a pre-flight request, where we would have the HTTP options method, and the whole purpose of it would be just to get the CORS headers to decide if we can make the request or not. The issues with pre-flight is that it kicks in only on specific conditions. It kicks in only for some HTTP methods, which are delete, post, patch, everything except get and post. Hear me well, not get and post. And the second condition is custom headers. So the term is a little bit overloaded. There is a specific list defined about what we consider non-custom headers, and all the rest is custom. But in my case, I didn't use any of it. And that's the reason why I was able to push a post request without being blocked by pre-flight. The reason you might see pre-flight all the time for those of you working in an architecture with a single page app is that most of the time we are using the header authorization. the header authorization is considered as custom. And that's the reason why there is some pre-flight made even to get request, get post. You see that all the time. But that's because there is a custom header. So the cores are useful, but in some case, they are not enough. That's the reason why CSRF token is very important. That's not to say that you should discard them. So please, I mentioned that already, please do not put some wildcard, especially at the beginning of the project, because you can be sure it's going to be shipped to production. So now it's a time for me to be honest. I lied to you a little bit. The attack that I mentioned before, the clickjacking and CSRF, they are not as easy to pull out since a few months. The reason is because Firefox pushed, I think on version 103, some extra security that aligned with what Chrome did, which is on these cookies SAM site, they put it lax by default, which is a little bit inconvenient. But the reason why I still showed you that is because CSRF and clickjacking are not dead yet. They are not dead for one reason: subdomain takeover. And this specific subject needs to be covered. It could be a full talk, but I try to be quick. Subdomain takeover speaks for itself, right? You take over a subdomain. There is those Uber, Snapchat use case, Ubiquity, that got hacked with that. And when you look at the the description of the vulnerabilities, it was really, really stupid. But that happens. I'm not finger pointing anyone. What happened is DNS on some big organization and even small can be huge. Right, and we tend to put some subdomains for I don't know, the new blog, or for this new tool that we put in place. I don't know, Workday, whatever, GitLab. So what happened is that we put this C name on the DNS to point to the platform, and then we kind of forget about it. Maybe later on the blog wasn't successful enough, the proof of concept was discarded, these kind of things. So what we do is that we delete the blog on Tumblr, we delete the app on Heroku, we delete the stuff on the platform side, and then we forget about the DNS. That's what we call dangling subdomains. And that's used quite a lot, just at least to fingerprint any target, and that can happen to you. So please be careful about subdomain takeover, and be careful about all the attacks before, because they can be subject to these kind of things. You might say, yeah, well, subdomain, you need to find those dangling stuff, right? But actually, enumeration is very easy. So I'll let you look at the subject with all the mechanism around certificate transparency. It's very easy to find any subdomain for a company, and there is fuzzing tool. So that happens. And to just go further, there is a study on the whole subject on can I take your subdomain.name. So you can have a look. All right, so now that we have CSRF protection, now that we have the clickjacking protection, what can I do? All right, so let's talk about the real stuff. Remember, I have this page, right, with the where I can post a new talk. So what should I do with it? Injection, maybe?
Check if you can SQL inject.
I'm just on the headers and browser side stuff, but almost that. JavaScript injection. Just that. Let's see. So I'm gonna test that, right? We'll see how it works. Test. Let's go. Oh no. It's not gonna work. I need to refresh it. the reason is because I activated CSRF by the time, so I got tricked into that last time. All right, so what if I post that? I don't know. I'm not really subtle, but let's see. Yeah, too easy, right? Let's see. Never know. Nah. Not only that it didn't work, but also I got like doxed. I got so not really helpful. The thing is, you might know that this whole thing is about XSS. The thing is with injection that we always or often think that it's just about the input fields, right? But I'm doing a request. So the other input I can maybe modify is headers. We're talking about headers to protect us, but maybe headers to hack us. So what if now, sorry, little trick, do that. What if I modify the user agent headers? Very easy. I've got this small add-on on Firefox to actually modify it, right? So let's use that and let's try to be more subtle. Test. No, not gonna work. Test, test, test. I'm not injecting anything on the form, right? Just on the headers. So let's go. And now, let me just see. So I've got my new talk here. See that it's still submitted, right? The one I'm targeting is still submitted here. It's not accepted. So I go here. Of course, I'm a really bad speaker, so what I propose is really not interesting. And then I come back, and then accept it again. What I'm showing you is very easy, actually. I mean, all I did is just injecting some piece of JavaScript. But what I did is, if I go to the debugger, I actually managed to inject this evil stuff. And what the code is, so now I need to. So you need to look at this. What I'm doing here, first thing I do, I pick up the CSRF token because I know it's protected. And then what I do, well, at the end, a lot of stuff. But at the end, what I do is that I retry my AJAX call to the status endpoint, but this time with the CSRF token. It works. But what I'm doing also is that I'm picking up the cookie here. What I do is that I send it to evil.fr on Lix. And what happened is that I got it. It's on evil.fr stuff, so I got it stored, and I got the G-session ID. So it's a cookie. What now happens if I go on YOLO CFP? I'm unauthenticated, right? Because I'm supposed to be the attacker, but now I've got the cookie, so I can set it manually. Storage. Ah. All right. What if I come back? I'm authenticated. Here we go. So, I mean, all of this is simple. I guess what I'm saying here is that XSS, if you get an XSS injection, it's game over, really. So, I guess what I want here. Yeah. So it's called XSS. XSS injection, and the one thing that you will want to know as HTTP headers is the CSP, the Content Security Policy. Because I quickly mentioned that for the iframes, but actually the same principle applies for every single element that you can have on a HTML page. JS, CSS, iframes, media, video, everything. You can specify in the CSP the exact domain you trust from which you want those resources to be loaded. And very interestingly, the first thing you do on the CSP is this default source self. What it does, it says, I don't want any inline stuff. I don't want any inline JS and inline CSS and so on. Every of those content needs to be from an external file and needs to be loaded from those trusted domains. And that's how you try to secure your mitigating XSS, because you just say that I don't want this stuff to be injected. And in my case, evil.fr would certainly not be whitelisted on the CSP, right? So my injection wouldn't have worked. The CSP would have blocked it from the browser side. However, CSP can be huge. Who apply the CSP on their application website? One few. I guess you know how hard that can be, especially on existing applications, because resources might be loaded from really multiple places. And I take, for example, the one from Twitter. You can go on any big sites. You will see a CSP that is huge. And that could be also scary because you don't want to break things, right? So to help you out, there is a way to use the CSP in a non-blocking fashion. You can specify another header, which is called Content Security Policy Report Only, where you say, you know what, the policy that I specified you, if you see any violation of this policy, don't block it. Just report it to this endpoint. You can specify it, report it to this endpoint, and I will get the information, I will adapt, right? And that's interesting because then you can go iteratively. You can have something like blocking on the standard CSP, very few things, and then you can iterate and test on the non-blocking header to see if that works out. And after a while, you migrate that to the blocking CSP. Very interesting. But also, I stole the cookie, right? So what happened is that in JS, I could access the cookie. And I said there is several options on cookies. I talked about same-site. I didn't talk about HTTP only. HTTP only, very simple. It just blocks the access from JavaScript, right? The cookies are only there to be sent to the backend, no JavaScript. That could have helped. With HTTP only, I couldn't have stolen the cookies. But yeah, one thing I can't argue enough on the XSS is just sanitize and escape. So I guess nowadays that we are working with a lot of single page app. The single page app framework are doing a good job on that, but we are also seeing a lot of discard of those security on single page app, especially when we have to treat with HTML editors and these kind of things. So be careful, it's not because you're on a single page app that you're protected. And if you're not on a single page app, you really need to look at this. The most important thing is the output. What's important is what it will be displayed afterward on the page. It's not necessarily what's given as an input, right? So you can, of course, sanitize and escape the input, but you need to pay attention because what will matter is what you will display afterward. Another thing, so let's close the XSS stuff. Man in the middle. Usually this stuff is like, yeah, okay, that's kind of an advanced targeted attack, right? Not easy to pull out. I encourage you to look at ARP spoofing. There is a lot of tools that can help in here. Man in the middle is not necessarily difficult to put in place. Not talking about like all the public network that we find these days in many places. So we say HTTPS all the things, right? TLS all the things. But does it really matter if you keep the HTTP version beside it? I don't know, because I could give a link to someone in HTTP, they would follow it, and then if I'm able to read the traffic, I could read the content. So one header, very easy to put in place. HSTS. HSTS is telling the browser that for any connection that is asked in HTTP, please turn it into HTTPS upfront, right? Even before the request is made. One trick, HSTS only works if there was a prior connection in HTTPS made to the server, and then the server replies with HSTS. Only then it works for the next connections. But still interesting to put in place. XSLeaks, I'll just briefly talk about this. That's for you to look at several other headers in security. XSLeaks is this kind of attack where we try to use side channel attacks on browsers. And side channel attacks, when we say side channel attacks, it's not necessarily something super complex at the CPU level. We've seen attacks on browsers based on the time it takes for a page to load, right? Like if you try to go in a URL and then it takes I don't know, like few seconds if the write is done, but like few milliseconds if no write is done because you don't have access, then you can leverage that. It's a side channel attack, and you could use that in combination with iframes. So there is a lot to talk about XSLeaks. It could be a talk in itself. But please be aware of this, because the new headers that are coming in, some of them are related to this class of attacks. But just to go like beyond that for you, I really encourage you to look at this project from OWASP Secure Header Project. Google that, you will see a lot of content, all the headers recommended, how to implement them, and all the details, and sometimes the CVEs behind them. So please look at that. And then in terms of tools, we've got OWASP Zap that you probably know, really interesting to put in place in your CI/CD pipeline. These kind of things would detect if you don't have really basic headers, like HSTS would be one of the first findings, these kind of things. But OWASP Zap is really interesting. Burp Suite also just goes a little bit beyond, but any people in InfoSec already knows this stuff. By the way, Portswigger is a company, and in their website they have tons of content, blogs and articles around security and development. So you can have a look. And for the purpose of this talk, I built this CFP stuff. But there is similar apps that are vulnerable on purpose so that we can learn. One of them is OWASP WebGoat. You can play with it. It's very didactic, and you can play to hack and try to make your way through the application. Same for this DVWA vulnerable web application. And that's it. Thank you very much. So I've got 6 minutes for any question. I hope I didn't put you asleep. I've got one. I don't know if there is a mic or anything for questions. Okay, so I guess I'm gonna.
Yeah, hey there.
Hello.
Is there like any? I mean, you gave examples for Spring Security, and it's kind of relevant to us here today. So is there any way to sanitize things that are not data that like input data, maybe like the URL or like,
So,
yeah, so, or headers, stuff like that?
so the question is there a way, like a classic way to know how to sanitize this piece of inputs and like URLs and...
Yeah, I'm asking that because I specifically like sanitized HTML,
Mhm.
but I haven't seen any tools for sanitizing JavaScript and stuff like that. I bet there are, but do you have any recommendations on that? Sanitize stuff that are like,
Yeah, well, I don't have recommendation for JS especially, but I know that sanitizing is a kind of a cat and mouse game because there is always new ways. Um, so you've got plenty. So one thing is that usually for this kind of libraries, you will find good recommendation from either IETF, OWASP especially. And usually we need to look at those recommendations because there is so much library that could help us on that, but some of them are not maintained anymore, not up to date or not ideal. So we need to be really careful and maintaining the library we use for sanitizing. It's a tough subject.
think so.
Okay. Oh yeah. Sorry. Oh, some. Okay. Ah yeah. Cool.
When exactly was the JavaScript that was injected with the header? When exactly and where was it executed? What was the
Yeah, thank you so much for the question. That might have been confusing. So the question is, how come that this user agent header got executed, right? I put this user agent header, and at the end, you got it executed on the page. There is one step I forgot to mention, and thank you for the question. On the application, there is this on the detail page of the talk. At the end, I display the user agent. I display it like some kind of tool to know like where was coming from the user or what kind of device they were using. So I displayed it, and that's because I displayed it that this user agent stuff input got actually into a valid attack, right? And that's the reason why I insisted on it's about the output. It's about what you display on the page before what you sanitize as input. That's the missing link, and thank you so much for the question. All right. Then I guess I can wish you all a very good day, and thank you.